Hi, and welcome to another feedback interview for the Zero to ASIC course, this time from Kyrylo. How's it going, Kyrylo?
Going good. What about you?
Yeah, I'm well, thanks. Thanks very much for agreeing to this. Maybe you can just tell us a little bit about yourself, your background.
Sure, yeah. So I'm a engineering student, doing mechanical engineering actually, but I'm interested in all the parts of engineering. It could be electrical, software, and so I guess we're gonna get into this later. But part of my interest is silicon, and so that is the main reason why I decided to take this course.
What kind of excited you about silicon?
I think the idea of computation is very interesting.
Hmm.
Being able to run AI or any other type of computation to improve humanity. Obviously, it's a big benefit,
Hmm.
and so that's why I get interested in this.
Okay. Um, what part of the course did you most enjoy?
I think I'm gonna be pretty unpopular here, but the magic stuff, it was pretty fun.
Okay. Yeah. So have you? I don't know what that means because obviously silicon is magic, but there's this old school tool about 40 years old called magic, which is what we use for doing kind of analog layout stuff. What made you enjoy it? Just like the drawing on.
I think connecting the fundamental physics to
Mm,
actual, seeing how it kind of done on silicon.
mm,
That's pretty interesting because you usually work, let's say if you work with Verilog, it's kind of like a black box in a way, right? You write software, you write code, and then somehow, in some way, it gets actually, you get at the end through all the flow, you get the GDS files, right?
mm.
And so, what does that actually mean? And I think, Magic, this tool actually allows you to have a chance to, have a taste of how it feels like to actually be low level silicon design.
So when you like draw a MOSFET in Magic in part one of the course, then later in part four, when you see all these thousands of transistors from your Verilog, it kind of helps you
Right.
see.
Yeah.
Yeah.
Yeah. I think I just like understanding kind of everything, and I don't like operating with a black box, so to say.
Yeah.
So, um, all the parts were interesting, but this one was actually, it's like kind of clicked. I was like, oh, okay,
Mm.
here's how, if I ever want to make, a transistor, here's how I would do it.
Yeah. Yeah. Oh, interestingly though, now that I'm working on the analog course, you draw your transistors usually in the schematic editor first, and then you import them into Magic, and it draws the transistor for you. So now what I'm doing more of is um, the transistors get created automatically still, but I wire them up manually.
Right. Well, I guess it's still quite interesting to see
Mm.
how the whole design comes together.
Yeah.
So that's plus.
And what was the most valuable part of the course, do you think?
I think I would say the community, actually, if that counts as a part of the
Yeah,
course,
sure. Yeah.
because I think people were just very helpful. I met a lot of interesting people throughout, and then even with some of them, I went to a few events in real life, and then I saw their name tag, and
Yeah.
then I was like, "Oh, your name seems very familiar."
Great.
Um, and then it turns out that yeah, we saw each other in the weekly meetings.
Cool.
Um, yeah, so that was great.
Yeah. Great to hear that. Would you recommend the course to someone else?
Yeah, absolutely. I think um, learning, you know, learning something new in general. If you're just interested in diving into silicon and you don't know anything about it, this is a great course. And I think even if you do know something, I think it's a still great value proposition. Just because the community is so great. Again, the videos are still, I think, could be helpful at any level, especially with the tape out stuff.
Hmm.
Um, yeah, and I think there's just a lot of support, and the community is again very, very supportive of people making things.
Yeah, great. Okay, so you've just, as part of the course, you've taped out on Tiny Tape Out 6, and this is your design. So do you want to tell us a little bit about it?
Sure, absolutely. So the initial idea was, you know, AI is a big thing, obviously, and I was just very curious how, how does AI happen in hardware?
Hmm.
And so fundamentally, it's all about matrix multiplications, right? So you basically multiply numbers, but you want to do it in a smart way, right? And so I would say one of the most probably typical designs for, for matrix multiplication is systolic array multiplication, which I guess people can read on a little bit
Mm-hmm.
online. I don't really have resources here. I guess I could provide them. But in a way, you can think of it as a smart matrix multiplier that does it in a fast way, faster than you would, let's say, do it manually.
Mm-hmm.
And so, yeah, basically, this took me, I would say, uh, probably a bit more than 20 hours of work, 20 to 30. I initially
Okay.
had like a big design,
Hmm.
which was too big to, I think, fit on tiny tape out, or
Yeah.
at least it would take a lot of cells,
Yeah.
which would be quite expensive. And so I decided to kind of narrow it down to a communication protocol so you can talk to the chip, send data to it, and send data back from it. And then you can actually multiply 2 by 2 matrices together. And so
Okay.
these are two main components. And so I guess you can show let's take a look what I can show.
Yeah. And just show us the cell usage first. Just up a little bit.
Oh,
Keep going up.
oh, that,
Okay,
yeah,
yes, there we go. 6,000 cells. Okay, so it's quite a chunky project.
yep.
About 6 tiles worth? 50%?
Yes, yeah, yeah.
Yeah. Okay, great. Yeah, show us the layout then.
So here's the layout. Here's the 2D view. You can also watch it, take a look at 3D,
Yeah.
but
Yep.
I think it's gonna
Takes a
take
little
some
bit.
time
Takes a
time
bit of
to,
time to load, doesn't it?
yeah, yeah.
Yeah.
But
Great.
yeah, I mean, it's great to see how actually, you go from code, because usually what I do is, coding, and then it's always like a big kind of mystery to me. How
Mm.
does it actually come to life physically?
Mm.
And so, having all the tools built, to actually also go from your Verilog directly to a tape out is very convenient.
Mm.
And the process is very quick, and I think I had a great experience, solving a lot of issues, a lot of bugs in my code, and then actually having the design done.
Nice. Good feeling.
Yeah, absolutely.
Yeah. Is there anything else you want to say?
No, I mean, generally, just want to encourage people to go explore stuff. I think silicon is, we probably all know that AI is not going to go anywhere, for example, and AI is not the only thing that uses computation. And I think it's, at least for me, and if you're curious how all the modern technology works, like how all your phones work or any other electronic devices, I think this is a great course to take to get exposure to that.
Great. Thanks very much. Thanks for your feedback. Appreciate
Thank
it.
you. Thank you.